Okay, thank you all for attending. This month, our topic is going to be our tiny Modbus RTU modules. Let's begin. Okay, here's our agenda for today. First, we'll give an overview of Modbus RTU IO modules, their features and how to use them. Then we'll show you how to add remote IO modules to an existing Modbus system. And finally, we'll show you how to do simple data logging using our TM modules for low IO counts. ICP-DOS was established in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP-DOS USA was launched in 2001 to support the North and South American markets. Our products are ISO 9001 and RoHS compliant, and we're a Windows embedded partner. Concerning Modbus compatibility, Modbus RTU and Modbus TCP are open source and royalty-free protocols designed by Modicon originally. They're made for easy third-party implementation and compatibility. Modbus RTU is the most popular industrial protocol out there. Many PLCs, SCADA, data logging, and automation software provide communication drivers for Modbus RTU and Modbus TCP because it's the most popular. Let's see, for Modbus RTU communication, it requires an RS-485 converter. If your PLC or SCADA system or HMI already has an RS-485 communication port, great. If not, we suggest using our TM7561, which is a USB to RS-485 converter. This is great for configuring the modules and for testing the modules. This will give your PC a RS-485 port to communicate to the modules. Modbus RTU has many limitations and benefits. First of all, it can communicate up to 4,000 feet along a single twisted pair of RS-485 wires. So it allows for long distance communication, and you can supply communication to up to 255 modules or individual nodes. Each device must be daisy chained along the single RS-485 bus, but you can use repeaters and hubs to go different directions and branch off as well. Serial communication tends to be on the slow side, but for data acquisition and some control applications, slow is relative. So please consider Modbus RTU as a well-known established protocol. The network must be planned due to the distance and wiring limitations. Again, because everything must be along a single RS-485 bus. As an example, like buildings with multi-stories, you'd probably want to use a hub because you'd have, say, one branch per level of the building. Or if you have your control center in the center of the room and you want to branch off into the different corners, you'd also want to use a hub, or you'd have to plan the network out well to have everything be able to be along a single RS-485 bus. Because of this, it's not easily modified, but you can add repeaters and other devices to branch off if necessary. Modbus RTU is great for small applications like controlling a single machine, data logging at a desk or in a laboratory, or for industrial controls using a PLC. Here's an overview of a simple architecture. On the left side would be your controller PC, which would be a Modbus RTU master in this case, an embedded controller or PLC, which could also be a Modbus master or a controller. The main thing is the left side is the single RS-485 master device. This will be the device which would send requests for information from the individual modules along the RS-485 bus. So you can only have one master in this setup, but it would be an RS-485 device which would have a Modbus driver and you can communicate to each of the slave devices on the right side, any one of them. Each device must have its own unique address, so only that device will respond. If you do have devices with overlapping addresses, that's bad configuration and it won't work. So you need to be careful when configuring these modules. Here's a comparison between our three series, which are similar to the TM module. So first is the TM series. These are the tiny modules. They have lower I/O counts, and you can only connect a maximum of 32 nodes per bus because of the bias circuit built into it instead of 256. This module can communicate using DCON protocol, which is an ASCII-based protocol, Modbus RTU, which is the topic of this webinar, and Modbus ASCII. So you can configure that using the utility, which I'll show you in a little bit. Our i7000 series is DCON protocol only. Again, that's the ASCII-based protocol. And the M7000 is very similar to the i7000, except it's DCON or Modbus RTU, which is the very common protocol. So if you have a PLC or master device which communicates Modbus RTU, you want to consider a TM series for low I/O count applications, or a combination or M7000 or rack I/O systems for larger I/O counts. And also consider the number of maximum nodes per that are allowed along the RS-485 bus. This is for the M7000, i7000. The 256 is due to addressing. For the TM series, the maximum node is based on the biasing circuit of the TM series, but you can use repeaters and add more nodes if necessary. That's just the recommended count. Let's see, the TM series is made for low I/O count applications. Note it's a smaller module in profile, but it's also got less terminals for wiring, so therefore less channels. The M7000, i7000 would be for higher I/O counts or applications where you need more than the 256, or I'm sorry, more than the 32 nodes. The resolution for the analog I/O is greater in the M7000 series than the TM modules, but for temperature and most analog applications, 12 or 14-bit would usually be sufficient, but again, that's based on your application. The dimensions are much smaller for the TM series. Note the dimensions on the bottom. Let's see, for the TM series, they're compact Modbus RTU and DCON protocol modules, which also communicate Modbus ASCII. We provide analog and digital I/O combinations, which are very popular, and you must choose based on your application. They're easy to configure and integrate with existing HMI and SCADA platforms that have built-in drivers for Modbus RTU or an ASCII-based communication system. You also need an RS-485 port, of course, and the PLC would specifically say Modbus RTU. If you need help in determining whether your PLC or existing system can communicate by Modbus RTU, please feel free to let us know, and we'll help you with that. Here's the common features for all the TM series, or most of them. They're RS-485 based, so it can be used in multi-drop networks. It's two-wire RS-485, so it follows the standard. It does provide a 5-volt bias voltage for the TM series. Let's see, the I/O types are programmable, and the ranges are configured using our DCON utility. They're easily mountable using the DIN rail clip on the back, shown at the bottom is a profile. They're built for rugged industrial environments, and can be used also in an enclosure if necessary. The output modules have the dual watchdog feature built into it, along with programmable power on and safe values. The DI provides a latch function to catch the fast switching of inputs. There's a low speed counter in most of our DI modules. Provides communication protocols, DCON, which is again an ASCII-based protocol, Modbus RTU or Modbus ASCII. They're easily expandable and have a tiny form factor. Let's see, here's a selection table of part number breakdown for our TM series. The TM is a series, followed by the input type and the output type. And we provide photocoupler, analog to digital, or analog input rather, and thermistor inputs. We also have a digital output module that's not shown here, or actually it is. It's in the table on the bottom and represented by DA instead of AD, and the output types are shown there as well. So again, these modules have different numbers of channels and types of channels. You need to pick the module which comes closest to the I/O count which you want and the I/O types you want. All the modules have RS-45, and all the modules can communicate Modbus RTU, Modbus ASCII, or DCON. That's settable in the configuration tool, and by default, it's configured for Modbus RTU. Let's see, these are most popular ones are the TM-AD5 and the TM-THH is also popular. It's a 8-channel thermistor module, and the TMR5 is a 5-channel relay output module, also very popular in building automation applications. Here's a I/O information for our digital modules. Note that we have different modules for different types of inputs. Our default is wet context, which means they can be syncing or sourcing, so be careful on that. Note the DC voltage limit on the digital inputs, and the maximum counter is 16 bits in these modules. If you do require 32-bit counters, our M7000 module is the choice. And we also have higher speed counter ability for those M7000 modules. The digital outputs shown here are syncing and sourcing modules, but we also have relay modules. Let's see. Yeah, pretty straightforward for these. This is some information on our analog input modules. Again, note different channels or different channel counts and different channel types. So you must look at your input range and match it to the table shown and number of channels. Let's see, also note 14 or 12-bit resolution. Let's see, when connecting to third-party devices using these modules, it's very easy because most manufacturers of PLCs, HMI, and SCADA have Modbus RTU communication as a option or built in. Because it's the most popular protocol out there and it requires simple RS-485 communication, which most PLCs have built in, you just can easily connect these to existing PLC for a few I/O channels or for additional I/O, like say at a remote location, meaning within a building, of course. Let's see, the PLC must have an RS-485 port. The master device must be able to communicate Modbus RTU or ASCII or DCON protocol to use the TM modules. The TM module is configured using our DCON utility. Within the utility, you want to configure the baud rate, the parity, the Modbus address for the specific TM module, and the AIO or DIO configuration. Let me just go to the next slide and show you a picture. This would be a configuration page which would be from our DCON utility. This should show roughly the settings that you can use within the TM modules. From the protocols, the drop-down box, by default it's Modbus RTU. You specify Modbus RTU if that's what you want. The address is the second line. Each individual module must have its own unique address, numbered between 1 and 255. The baud rate for all devices along the bus must match, and the data formats and input ranges and stuff, that's module dependent. And when you do have this connected through a decon utility, you can also monitor the current channel status on the right side. It'd be similar to this for different modules, but for digital modules, you'd see on-off as opposed to a numerical value. And for output modules, whether it be analog output or digital output, you can actually manually change the value of the output using this utility. Let me go back one and continue. Let's see, from the master side, you create a configuration using the baud rate parity, Modbus address, and AIO configuration, which you use the decon utility to the module, along with the Modbus register table. At the bottom is a little sample. And this sample registers 30,001 or 3x registers. Start off at 1 and continue to 8 for 8 individual counters. So if you wanted to read the second counter, would be 30,002, so it'd be a 3x002 register. And actually, I do have the full manual. Okay, here's the manual for one of our TM modules. I think this is our TMR5. This is the full address table, just so you can see that it's not just the ones shown. For the I/O channels, it'd be these right here. But you can see the full register table here. And again, it's in the product manual, which is downloadable from our website, or we can send it to you by email. Next slide. Okay, when to use the TM module. The TM module is great for PLC and HMI applications where Modbus communication is a available option. The PLC must have an RS-485 port, but since Modbus is a very common protocol, our modules are made to connect easily to third-party PLCs and HMIs and SCADA systems to make it easy to use and easy to add. Data logging applications using our EZ Datalogger, which I'll show you in a little bit. It's great for like LabVIEW applications. LabVIEW does have a driver for Modbus RTU devices. Building automation, like when you want to monitor, say, occupancy, temperature in a building, in different rooms, different areas, and then bring it to a central control center. Let's see, assembly line applications and conveyor applications are great because, again, it's along a single RS-485 bus, so you can connect nodes along the conveyor or assembly line. Counting applications, very simple and easy to use. Just connect a sensor to the digital inputs, and for each sensor input, you can count and you can see the count. You can data log it or monitor it. For monitoring control applications are also great. Specifically, like solar applications, you could monitor input and storage capacity. Anything with analog output can be connected to our analog input modules so that we can log the data. Next, we'll go over a little bit of our EZ Datalogger. EZ Datalogger is a software that we provide free and easy to use. It's a simple SCADA system that can be used on a Windows PC. It comes in 2 versions. The light version, which is free. There are limitations, of course. For the free version, you must have at least one of our data acquisition modules connected. The TM series do count, so you would be able to use this for up to 64 tags. If you have a larger application, you could purchase the professional version, which has higher I/O tag counts and additional features as well. Let's see, EZ Datalogger is great for small data logging application and small I/O counts. It's a user-friendly interface, and most people just want to create a simple data logging application where you can see a trend curve possibly, or keep a count in a database. It's great for that. Let's see. Okay, now I'll show you a live example of how to use our EZ Datalogger. This is the interface which first comes on board when you start up EZ Datalogger. I'm going to create a new project. Let's just call it TM sample. Okay, it closes and then reopens. Let me bring it back over here. Okay, so the first thing you want to do is go to Group Setup. This is where this is the Group Setup screen. Okay, so from here you must create a driver connection. In other words, Modbus communication. Then you add your devices and add your I/O channels. So you first click on Install, and a window like this will pop up. You want to note the protocol which you'll be using. For our TM series, you can use Decon protocol or Modbus Serial, which is Modbus RTU. Both are supported in this, but since this webinar is about Modbus RTU, we'll go Modbus Serial. You select the COM port which the module is connected to, and the baud rate. Usually our default is 9600, so I'll select that, and 8, none, and 1. Then you click Install. Note that the driver will appear showing which COM port's connected. Then you can click on adding a device, which, click one more time. Okay, which pops up a window like this. Note that you want to select the driver that's associated with this. You can have different COM ports and different drivers active at the same time. For this, since we want Modbus Serial and the connections on COM9, from there you would select the device. Since you're not using our M7000, you will be using our TM series. For this, let's just select our TM88 since it's an analog module. This module by default has 8 analog input channels, so it populates down here with analog input 0 through 7. Input types are integer, and if you have multiple modules, you would change the slave ID to match the individual modules. Then you click on Add, and the I/O channels will be populated in the AI channel list. The tags are shown here. You can double-click on the tag and modify its properties. If you did need to do scaling, that's done up here. And if you needed to set alarm values, that can be done here as well. Let me just close this for now. And from here, you would just add the channels to the channels to be logged, which would be shown here. So if you want to add different types of channels, you just click on the different radio or different buttons and populate the different types. Since this module only has analog channels, I just populated the 8 channels of the analog input. And then from here, you can click on Home and go back to the main screen. Normally, you'd click on Start if you had the module connected, but since I don't, I'll just click on Simulation. Same thing. If you click on Trend, you'll see a trend curve, and you'll see the values appear on the right side. Okay, and the result will look like this. Once you're done, you can close this and view your data log. To do that, you click on Open Database. And you'll see a little list of all your databases. From there, you can click on the database in the work group and load the table or load a historical trend curve. From EZ Datalogger, you can also export the data in either ASCII or CSV format. And if you needed to do some logic to control devices, you can also use control logic feature shown here and use if then else statements to say turn on alarms or send email messages. Let's see. Okay, that concludes our webinar. If you have any questions, please type them in the chat box and I'll be happy to answer that for you. Also, if you have any applications or want to discuss using the TM or any of our modules with any PLC or controller, please feel free to give us a call and we'll help you choose the appropriate part if you need help. Okay, I guess no questions, but if we can help with any questions or anything after the webinar, please feel free to contact us. Our contact information is shown. We'll have another webinar next month, and the topic will be announced in our newsletter. Thank you for attending.